Today we will be solving Fablong challenge. It's a live contest going on. Now the second question is n queens puzzle solved. We will see what it is asking. Chef being a chess fan, okay. Chef is a chess fan, it is given. Was it after victory? He read the following news. Michelle Simkin and postdoctoral fellow. Okay, we will highlight some important instruction. Okay, we cannot because it's a link basically. N queens can be placed. Okay, what I'm getting is simply it's like n queens can be placed on n cross n chessboard so that none attack each other. Although the formula is valid for larger n, like we have to find something value of f of n, and f of n is defined something like that. Okay, for a given small value of n, we have to round our answer to the nearest integer. Okay, like greatest integer function, not greatest integer, nearest integer. Simple. Input format t, t and n. For each test case, output a single line, the value of fn rounded to the nearest integer. Okay. When n is 4, answer we are getting is 0. And how we are getting, we can see that. Okay, it is a simple formula given. F of n equals to 0.143 into n and whole to the power n. Okay, so when n is 4, it will be like 0.123 into 4 to the power 4, and becomes 0.107, and we have to round our answer to the nearest integer. Okay, it is given round answer to the nearest integer. The only thing that we have to do is we have something of f of n, and it equals to 0.143 into n whole to the power n. Okay, now it will be something like, depending upon its value of n, we will get something 1.8 and let's say 1.2. So it is given that we have to round off our answer to the nearest integer. See, here 1 is itself an integer, proper integer, so we will submit we will output our answer directly 1 if it is an integer. If it is an integer, see, it is 1.2. 1.2 is basically 1 plus 0.2. Okay, so its integer part is 1 while its fractional part is 0.2. We have to round off our answer to the nearest integer. Well, the nearest integer is 1. Okay, if we have to make it 2, we will have to add 0.8, and adding 0.8 is considered as expensive as compared to removing 1.2, so it will become 1. Now it's 1.5. Now 1.5 seems to be an interesting case, because for making it 2 or making it 1, we need 0.5 in the same scenario. Okay, so we will come over it again. Now 1.8, again 1.8 is 1 plus 0.8. See, now 1 is a perfect integer. Okay, now 0.8. Now we can have two nearest integer to it, like 1 or 2. For making it 1, we will have to subtract 0.8, and for making it 2, we will have to add 0.2. Now which is easier, adding 0.2, because removing 0.8 is expensive as compared to adding 0.2. Okay, so its nearest integer will be 2 and not 1. I hope that makes sense. Okay, so now coming back to our doubtful case, it is 0.5. We will head over to the problem statement and we will see what they have given to us. See, it is given that print x if x is minus fractional part of x less than 0.5. Less than 0.5. It means if fractional part is less than 0.5. See, it is not equal. It is equality sign is not given. It means if fractional part is 0.5, we will plus 0.5, like we will. Okay, so it will become 2. So in this case 1.5 will become 2 and not 1. Okay, I hope it's clear now. Okay, so now the thing is that how we can do that. Let's say we have any number 1.2. We will first find out its fractional part. Okay, okay, and how we can find its fractional part? Simple, very easy. We can have a, let's say, number float. Let's say float fractional equals to integer of our answer. Okay, or leave that. Let's say float of our answer, minus integer answer. Okay, see, if we make a float variable, if we store our answer in a in a variable called float answer, and it is like 1.2. so what we will do like as per this formula. What we will do, float answer is basically 1.2 minus integer answer, minus we will typecast it, integer answer, integer of 1.2. okay, so it will be basically 1.2 minus 1, and we will get 0.2. Okay, let me write it clearly here. If fractional part is less than 0.5, okay, then it will see out integer of answer, else it will see out integer of answer plus 1. I hope that makes sense. Okay, we are basically checking if fractional part is less than 0.5. We are then it means that removing fractional part is much easier as compared to adding. So we are just simply removing fractional part, and we are printing out just the integer part of answer. Well, if fractional part is greater than 0.5, it means removing is expensive as compared to adding. Okay, like we saw in case of 0.8, when fractional part was 0.8, removing 0.8 is expensive as compared to adding 0.2. okay, so we are basically in else case we are basically incrementing integer part by 1 so that we can get our answer. Okay, so now we will head over to the solution. Okay, so we just have to, let's say we have our n, so let's say int answer. Okay, we will take float as answer equals to 0.143 into n, and we have to take its power as n. Okay, we have to take its power as n. So what we will be doing, power comma n. Okay, so we have to check whether this returns an integer or float. We have to check whether the power returns integer or float. Okay, so need to worry about integer like so. So now as discussed, we will have something called float fractional part. It will be basically answer minus, we have typecasted it, integer of answer. Okay, it will give us fractional part. Now we will have cases if fractional part is less than 0.5, it will see out. If fractional part is less than, it will see out integer of answer. Okay, else it will see out integer of answer plus 1. I hope it will satisfy all the condition. Okay, so we are basically now trying to run our code as per the sample test cases given. compilation error, float answer, n was not declared. Okay, we took a capital N, my fault. And now let's see if it works. Successfully executed. We are getting 036 as answer, and even output is 0 and 36, and well, n goes from 4 to 15. So I hope it will satisfy all the condition. Okay, we are trying to basically submit our problem now. We'll currently running test case 1, and yeah, correct. Okay, so we have successfully submitted 2 problems till now.